uh, Adding Value in Rail Freight. My name's Chris Field. I'm chair of the IMechE Railway Division in the South East. First thing I need to say is about housekeeping in terms of building information. I'm not going to bore you with any details. All I'm going to say is Toby is our host from a building perspective, so I guess if we see him running, we need to follow him. The theme of our lecture is really interesting tonight, rail freight. Not something I've got a lot of experience of. I'm very much a passenger rolling stock kind of person, so I'm really interested to find out a bit more about rail freight and what research is being done to drive it forwards in the industry. Pleased to welcome Aaron Rostron-Barrett, who is head of research delivery at RSSB. I know he's going to talk to us a little bit about rail freight in general, which, as I said, is really helpful for me to find out a bit more, and also about the research he's been doing. I know he's been in the RSSB for 8 years and in his current post for a year. So could you please join me in welcoming Aaron to the evening's lecture?
Thank you very much, everybody. So today I'll be talking to you about research, RSSB research that we've been undertaking and currently undertaking to add value for the rail freight community. There we go. So first of all, I'll just give a little introduction of who I am. I'll talk to you a little bit about RSSB and RSSB research as a whole. I'll then talk about freight, an introduction to rail freight and the importance of safety in there. And of course, I'll talk about safety. I'm a member and an employee of RSSB. I'll talk about how the research is helping what we're doing. I'll talk about not just research from a safety perspective, but also supporting growth in the rail freight market. And then I'm also going to talk to you about how we not just deliver research, but then how we make sure that that research lands to the right people at the right time so that they can take those findings, that it doesn't just sit on a shelf, and that we can make a real difference. And throughout the lecture, I will give some examples of how the research has really changed and supported improvement in the industry as a whole. So who am I? Well, hello, I'm Aaron Rostron-Barrett. I've come to the railways in a rather snake-like formation. I have to say, growing up, and it's as often is, my grandparents' fault. I used to be taken to the Keighley and Worth Valley Railway centre and line, and I really, really loved it. Growing up in school, I found out I was pretty good at biology, and so I pursued biology through my undergrad and master's and subsequent PhD. And it was only in the PhD that I realised, well, you can be good at something, but you don't necessarily enjoy it. So I realised at that point, well, I liked research, but biology, biochemistry wasn't really the topic for me. And that's when I changed. And I realised today I'm giving a lecture on engineering to a bunch of engineers, and I am a biochemist. So thank you for your time today, guys. But then in 2016, I changed course. I joined the Transport Research Laboratory and I started focusing on transport and primarily rail. And then in early 2018, joined the Rail Safety and Standard Boards, where I joined as a research analyst. And now I'm happy to say over those years I've been at RSSB, I now run that department that I joined all those years ago. So good thing. So RSSB, who are we and what does research do within RSSB? So I'm sure many of you are familiar, but I'll just give you a little background to RSSB. So RSSB is a membership organisation that is owned and serves Britain's railway industry. We were established in 2003 in the aftermath of the Ladbroke Grove rail crash. We were set up following a government review and a number of recommendations came out of that, including the development of RSSB. We're here to ensure that the railway is operated safely and in a cost-efficient way to the benefit of passengers and freight. Now, RSSB can be broadly split into these functions in front of you here: safety, standards, sustainability, and research. I'm here today to talk to you about research. But we live in a symbiotic relationship. Standards, safety, sustainability all inform the research needs and the research that we do. Not only that, we work closely with our industry colleagues and DFT. RSSB research is funded not through the membership levy, which the rest of the business is, but rather from a grant from the DFT. So that comes with a few stipulations. One of them is to do truly cross-industry research. Cross-industry research, which not one single stakeholder has ownership of. The classic example that you hear is adhesion. Well, is the problem the track? The problem the train? Well, actually it's both, and it's how they interact. And RSSB is the place at which we have those discussions cross-industry to address those system interface challenges. So, freight. Well, the research that we do more broadly, and really if I think about freight, is there's a couple of outcomes and a couple of things that we need to do to support the industry. We need to make sure that there is space for new products, new ideas to land. Now, why is that important? Well, I mentioned standards, I mentioned safety. Sometimes if we want to do a new way of doing something, something that hasn't been done before in the industry, with the best of intentions, sometimes the standards just don't allow it or they're silent on it. So in order for us to make sure that we can introduce a new way of doing things, a new solution or a new widget or whatever it might be, doing that safely, we might need to undertake some independent research. Now, I'm not talking about product development, that's for people to do private investment, but I am talking about from a railway perspective, are we happy to introduce this thing, whatever it might be, or way of working onto our network? And that's what the research department looks to do. We like to remove barriers. Aligned to that, we want to make sure that if we're doing something new and if it hasn't been done before, have we considered all of the safety risks? Have we addressed all of the challenges to make sure we can introduce a new thing in a good, efficient, effective, safe way? And of course, and I mentioned this before, helping to deliver new ways of working. Things that are safe, but things that are more efficient, driving down the cost. Making sure that we're providing clear, understandable, delivered guidance so that we can all do things efficiently in the same way, so that safety, so that efficiency is maintained. And I mentioned before, we've got some requirements. So the work that we do, that we fund, is cross-industry. It's at those interfaces. We also do a mix of the type of research, stuff that's high risk, high reward, that is maybe a bit more blue sky. But then we also do stuff which is short-term, incremental research, challenging certain things. And I'll talk a little bit about those different projects in the context of freight later. We need to make sure what we're doing has an impact. So where people have a challenge, they come to us. And the question that we ask when people say we invite ideas for new research proposals all the time. And I ask them two simple questions. What do you want to do? And why can't you do it? And that second question is really important, because if you can tell me why you can't do it, then we can develop some research to test a hypothesis to determine whether the reason you can't do it is valid, is still valid, can be challenged. And that's why it's important. So now let's think about rail freight, and let's just give a little bit of a background to rail freight in Great Britain. So first thing, let's ask ourselves, rail freight, where is it moved on the network? And the answer is, well, everywhere. It's moved across the entire network. But as you can see here on this diagram, there's a couple of big trunk routes. The first one, as you can see, really is on the West Coast Main Line. That shouldn't be a surprise to anyone. It has been historically called the busiest mixed-use traffic network in Europe, that line there. You can also see a few other routes as well, and I'll just highlight them. So traffic coming out of Southampton, that's Southampton docks, a lot of intermodal flows coming from the sea to Southampton docks and then being transported out of Southampton docks by rail up through Reading, up through Didcot, up to Oxford, and then through Birmingham, and then meets the West Coast Main Line. Also, you have here, just outside of Ipswich, you have again the port of Felixstowe, again a major hub for maritime intermodal coming into Great Britain, which is then distributed by road and by rail out to inland destinations. So, I spoke about the flows, I spoke about some of the ports you can see here, that's quite short, but there are a number of terminals, not just ports, but inland terminals as well, where freight, and we're not just talking about maritime, but other freight movements happen and transfer from road to rail, rail to road, and to our customers. I mentioned maritime intermodal. Well, what other types of freight does the network carry? Well, once upon a time, that line at the top there, coal, was huge. When we had coal-fueled power stations, most of that was transported by rail. We've moved away from coal-fueled power stations, and so that has massively reduced. We still have a lot of intermodal traffic. We've now got biomass traffic as well, which is used for the purpose of powering oil and petroleum and other aggregates used for construction, etc. Now, we've been talking about freight, but one of the comparisons I just quickly wanted to make is freight compared to passenger movements on the network. And as you can see here, it really is tiny. It really is small compared to passenger miles, kilometers traveled on the network per year. So it is something. Now, but how much freight is moved? So that's the miles, but how much freight is moved? Well, there is around roughly 72 million tons of freight lifted per year. That's been going down, and that's been going down. So that was the number in 2023, and that's a reduction of 10% from the previous year. So it is something that we need to do, and that's partly driven by the changing in things that are moving. And as I mentioned before, coal has been one of those things which has been massively declined to basically zero now. So that's what is being moved, but who are our customers? Well, I mentioned things earlier like biomass. So we have power generating companies that were using coal. There's a biomass as well. Oil and petroleum companies that are moving. One of the biggest flows that we have are freight trains carrying jet fuel into Heathrow on the North London line. That's a big part of the freight things. We also have trains carrying cars, funny enough, moving things. I mentioned the construction industry as well. A lot of aggregate is moved by rail, as well as aggregate, the steel for construction, and waste as well. So we have household and industrial waste, all carried by rail because it's a safer way than road, because it is contained, it is out of the way of the public. And of course, something I haven't mentioned, but it's big, is that domestic intermodal traffic for the major supermarkets carrying our goods. So on that note, while we see that freight accounts for a much lower percentage of the traffic compared to passenger, one of the things that the Director General of the Rail Freight Group says to anyone that will listen basically is, yes, there's more passenger services on the network, traveling more distance on the network, but not everybody uses a passenger train, but every single person will have a good in their kitchen or goods in their kitchen, which got to them by road, by rail. So whilst everyone is just using road for the purpose of their own commuting, and some are using rail, everybody uses rail for their goods and the movement of their goods in their kitchen. And that's why it's important. And it's important because of the environmental credentials as well, and society credentials. Now, For every one freight train on the network, that removes 129 lorries from the road network. That's big. Rail is much more environmentally friendly when it comes to the production of things like NOx and particulates. So there are significant health benefits by moving more on rail than there is on road. Now, one of the things I also want to mention, because it is important here, is the ownership of freight operating companies on the network. Passenger, it's all in public ownership, or it will be soon. That's not the case. Freight is a wholly and completely private venture. Their margins are much, much smaller. The way that they undertake their operations, therefore, means that they have much less meat on the bones, and everything is done literally by the skin of its teeth. In terms of what they deliver, they really sweat their assets. They really look to get the most out of everything. And that is important for some of the research that we're going to talk about in a moment. So we've talked about what gets moved. We've talked about where it gets moved. We've talked about who wants the stuff to be moved and who pays for it. But who does the moving? Now, there are a number of players in Great Britain, and the ones on the left, those three there, are the biggest by far in terms of miles moved. So DB Cargo, Freightliner, GBRF, those three account for 90% of the distance travelled by freight trains on our network. But there are a number of other operators that have significant specialism and are very important to the sector and to the GB economy as a whole. Just a couple of special mentions. So the Rail Operations Group, ROG, now that specialises in the movement of rolling stock and things like passenger, empty coaching stock movements. It also looks and supports the haulage of charter trains. Colas was a company that originally was primarily focused on plant and machinery, but recently have had huge growth in their freight operations as well. And of course, there's DRS, who specialise in the transportation of nuclear waste, but again have a large, in fact, a majority portion of their operation dedicated to the movement of freight more generally. So that's freight. But what about freight operations and safety? Now, I mentioned before that with freight, they are a private operation, and so therefore the things that they do are they operate in a different way compared to the passenger world. And I just want to take a moment to talk about some of the incidents and one particular here. I'm sure many of you will be familiar with Llangennech, and apologies for any Welsh people in the audience for my mispronunciation. What happened here? Well, there was 25 wagons carrying diesel fuel tank, and there was a derailment. And 10 wagons derailed, 3 at the front, they caught fire, and 446,000 litres of petroleum product was spilled. That's huge. Really, really bad. This happened in an area of special scientific interest, and the cost was extraordinarily large. What was the cause of the issue? Well, there were some bolts holding the relay valve in place. These were loose, and there was no washers present. The matting face of the relay valve and the pipe bracket had become separated by 1 to 2 millimeters, and the O-ring had moved. This impacted 2 other O-rings and air from the input and output ports, and it also impacted, caused the brakes then to be activated en route. The wheels locked up, creating a false flange, and an axle was derailed. This caused the wagon to derail, followed by further wagons to derail. 37 million pounds cost. Across the industry, a combination of Network Rail, a combination of the operator. Why did that happen? Well, we've spoken about the mechanism of what failure was, but fundamentally, there's questions around how well were these things maintained? How can we make sure that we're managing the maintenance of our assets? How can we make sure we're monitoring the condition of our assets? It's important that whilst we recognise there are benefits to moving things by rail, we can have long trains, a lot of freight and weight being moved. That comes with safety risk. We need to be cognizant of that and how we address and mitigate those safety challenges. That said, though, we've got to remember, we've got to remind ourselves, the GB Railway is a safe railway. It is incredibly safe. But when we look at freight, we see that of the higher risk train accidents, 38% of those are related to movement. And we think about then what I mentioned earlier about just how much traffic is moved comparatively rail freight to passenger services. That's a big number. It's a very big number. But RSSB does a lot of work to understand what those risks are, and I'm sure you'll have heard previously around the safety risk model that RSSB has, and the analysis that's undertaken to make sure we are addressing specific challenges and specific risks associated with the movement of freight goods, of any goods, of any passengers on the network. And this is where I just want to talk how research can help and what we've done in the past. So, signals passed at danger. Signals passed at danger. RSSB has developed a tool, the red aspects approach to signals. What this does is it uses readily available industry data, berth data, to determine where trains, where drivers are seeing or experiencing a red signal. That helps us understand SPAD risk, because you can't have a SPAD if you don't have a red aspect signal. So if we look here, we can look at this. We look at the SPAD risk, and we look and we say, well, okay, more passengers, we kind of expect that. And then you can see our freight and engineering trains. Okay, that's still high when we think of the relative movement of passenger trains compared to freight trains, but it's lower. That's good. But when we consider the experience of a red signal, then we control for SPADs related to the number of red signals that you see. Suddenly you get a very different picture. Suddenly we recognize, yes, there is a lot of passenger trains moving across the network, but for every red signal they see, they are much less likely to SPAD, according to the data. And this insight then helps us make interventions. And it's thanks to this tool then that further work has been undertaken to mitigate these challenges and work continues in that space. But that's where our research comes in, because we see problems before they start occurring. Here you can see the general trend of SPADs across the network, and it was going down. And it was going down from 2006 all the way down. We had a really nice low percentage, relative percentage by 2012. But we recognised SPADs was still a risk, and we wanted to do something about it. So we started developing, and we started creating and then productionising the RATS tool. And that helped us undertake the analysis I've just shown you. So it helps us now control and see and get better insights for where there is real safety risk. That's just one of the ways from a safety perspective that RSSB and RSSB research is trying to help the industry. Through better insight, through better information, we can target our interventions, and then other parts of the functions within RSSB can support the industry in delivering and identifying what those mitigations need to be and delivering to our needs. So let's talk about freight and some other research. So freight dedicated research. So we've spoken about safety, but it's not just safety, is it? It's growth. It's supporting good, efficient movement of freight on the network. And I pose this question, growth or decline? Now, the reason I say that is because, well, you can see there we've got a picture of the canals. And obviously that used to be our major route for moving freight across the industry. And recently we've had, I mentioned before, a decline in the amount of freight that's being moved by rail. So are we an industry, from a freight perspective at least, that's in decline or in growth? Well, we know that for CP6 and onwards, there is a growth target. The government, the previous government and this government, recognise the value of moving things by rail for the reasons we spoke about earlier. But we need to make sure that not only are we safe, but the rail freight offering is competitive. It's hard to be competitive because there are a lot of things going both for it but against it. Yes, we can move a lot of things and we're a low carbon transport option. So from a sustainability point of view, that's good. But introducing new services is tough. It's tough for a whole host of reasons. There are other services we need to get around. We need to make sure that we're timetabled well. We need to make sure we've got it. We need to get on and off the network to terminals. Well, there's only a finite number of terminals. We need more of them. It's expensive to build the infrastructure to enable that. And being frank, the road is really keeping itself competitive. Before we know it, we are going to have electric lorries. We know that our green credentials which are our unique selling point, are not going to be as strong in the future. So we need to make sure we're innovating. We need to make sure we're making ourselves as competitive as possible. So we have growth targets. How can we deliver those growth targets? Well, RSSB, as I mentioned before, we've always done research for the freight community. Primarily and originally it was focused on safety. But then about 4 years ago now, the freight community through the Rail Freight Group went to the DFT and said, we need more dedicated funding for research to support the rail freight offering. The DFT came to RSSB and said, can you help us out? We said, yeah. So from that, we developed a whole pipeline of research. Not just looking at safety. Yes, continuing to look at safety, continuing to be efficient, but also how can we help make the railways more cost effective to run our freight trains on them, to make journey times less, and to make the cost of moving those things reduced. Fundamentally, we identified 4 key areas that we needed to focus on. Route access to heavier, longer and larger freight. We've got an old Victorian network and we want to put big boxes through them. That's hard. How do we make sure we do that? We also have old bridges which aren't as strong as new material, and if we want to put heavy goods across them, we can come up with some challenges too. We need to increase average and maximum freight speeds, not just for the purpose of arriving at our destination 5 or 10 minutes early, but so that we can unlock new asset cycles, so we can get the wagons back out there making money. We need to, and we've spoke about this, ensure that our operations are safe, not just through the operations, but through our maintenance and through our monitoring of the conditions. We also need to continue the decarbonisation journey. Freight, whilst it is a low carbon option, primarily is still moved on the network by Class 66 locomotives, big old 30, 40-year-old diesel locomotives that do have a high carbon output relative to other rail locomotives and trains on the network. So we need to continue that. And we've got a big old pipeline. All of these came from those conversations and those ideas. What do you want to do? Why can't you do it? The industry told us, so we undertook a big pipeline of research, and I'm going to talk to you about a few of those now. So one of the things, we can make the movement of goods more efficient by having longer, heavier trains. I want to do that. Why can't you do it? 3 reasons. 1, my coupler strength. 2, the tractive effort of my locomotive hauling the goods. And 3, I need to fit around other services. So let's just take the coupler strength as an example, because we've done research to challenge all of these things. Coupler strength. That information is contained within this document here. I call it a document. It's an Excel spreadsheet with numbers in it that say this is the maximum trailing load you can have. That is the maximum amount of weight you can have behind your locomotive for different locomotive classes. This is the tractive effort piece that I mentioned, and different coupler strengths. That logic was created originally by British Rails, and it's in this document here, MT90. And fundamentally, that logic had not been challenged since it was first devised. Can you believe it? So the freight operating company said to us, I can't do it. One of the reasons I can't run my freight trains any longer is coupler strength. Well, let's revisit coupler strength and let's see if we can challenge those limits that are there. And for those of you that are interested, you can go on our website, you can find them. There are some codes here. If you type in those codes to our website, that will take you to the relevant piece of research. Let's talk about couplers. So in GB, we use these things called screw couplers. And here, just as a diagram, talking about some of the key bits. You can see there the draw gear, the coupling, the screw coupling, and the buffers. Now, sorry, I love a pun, so you'll have to bear with me here. I'm going to tell you about how this research really delivered value in a couple of ways, 2 ways. We have these traction ratings I mentioned earlier, 23 ton, 34.5 ton, 56 ton. Now, our research identified where those values came from, and there was a review of the safety factors, and two key safety factors here: the proof strength of the coupler bar and the braking strength of the coupler bar. And it was the lower of those 2 that enabled us, that determined for any given coupler what the maximum trailing load is from a coupler's perspective. We looked at those safety margins and those factors of safety, and we realized actually, given where we are now and given the new improved modeling that we can undertake and the testing that we can undertake, those factors of safety were really conservative, and they didn't actually follow today's standards in terms of defining what that factor of safety should be. So we challenged them and we increased them. Well, as you can see here, so what you've got this table here, and the thing I really want to show you is, and the thing you should really do is lots of different wagons with the different couplers on them. You can see here the number of wagons with the different couplers on. So what did we do? Well, we challenged. We didn't bother looking at the 23 ton. Why? Well, there's not a lot of them out there on the network. They're old. They're not really used for the purpose of freight anymore. Let's not worry, and let's not really focus on that. 34.5 ton. Oh, there's a lot of them out there on the network. Can we challenge them? Yes, we can. We can uprate them to a 40 ton coupler. And all of the information, all of the engineering. As I mentioned before, I'm a biochemist, so I'll let you do the engineering. I'll just tell you and claim the credit. We had an increase of about 16% in terms of its traction rating. That's big. That's big. But what else? But you can see that's a huge population. We looked to challenge the 56 ton. Well, actually, that was good. That complied with today's standards. But we recognise, guess what? There's loads of new couplers out there on the network, loads of European couplers, which are have much stronger hauling capabilities. And we're not accounting for that capability. So let's create a new coupler rating, 63 ton. And a number of those couplers and wagons, which were currently classed as 56, could be classed as a 60, or 63, sorry. And so you could see then all of a sudden, over 50% of the wagons on the network get an up rating in the amount of trailing load that they can haul. That's big. And that's for free. You don't have to do any more engineering analysis. No one has to go through any approvals. It's there, the operators can use it. Now, I mentioned that there's benefits in a couple of ways, so you'll forgive me. We created this just to demonstrate, because it's quite a hard principle to talk through, and it's just a bit easier to do it in a video form. Now, how those trailing loads were calculated wasn't just on the rating, but it also is dependent on the gradient. If you're trying to pull something uphill, guess what? There's more force going through the couplers. Now, how on a particular bit of geography, how that was calculated previously was it assumed it would look across that bit of geography and it would say, the worst case scenario is that 20-meter stretch where there is this very high gradient. And what they did was they assumed the whole train was experiencing that high gradient. Now, that clearly wasn't the case. But when you do assume that the whole train is experiencing that high gradient, guess what? Have a much lower threshold. If you're able, as we are now, to characterize exactly what that geography looks like, exactly how and where those gradients are, you're able to account for the real geography of the line. So even though you do still have that maximum gradient, you recognize it's not there and it's not putting force through the whole train. It's only through part of it. So you're able to uprate the total tractive effort that's being calculated. And you can see here, just to show, I think it's quite a nice demonstration here of how, even though you do have really roughly a similar gradient, by accounting for the actual length of that gradient, you're able to maximize your trailing loads. And so we did it. And then what we recognized, and it goes back to this point, how do we add value? How do we help industry pick up these findings, use those findings? Well, we had 100 and something page report, which went through in great detail the engineering justification and the calculations that you need to undertake to determine actually what your new trailing load limit is. Not really user friendly. So what we did was we took those findings and we packaged it up in a little model, which took those findings and automated it. Because we know we've got the information about what wagons are out there on the network. We've got the information already in our rolling stock library R2 that tells us what couplers those wagons have. So we can already update that and put that into a ready-made model for industry to use. And we did. So let's look at the benefit that these new traction ratings and new way of calculating the trailing load limits give us. So let's have a look here. So we're having a look across a bit of junction here. This is Haringey Junction. This is one of the limiting factors for one of our freight flows. And we're putting through and we're seeing actually what we can get. So if we see here, okay, from the original traction rating, we've got 21 wagons. Okay, that's okay. 21 wagons, can we beat that? Let's see now with our new traction rating. Thinking again about the same bit of geography, but using the new methodology to calculate it. Okay, we're at 21 wagons. Oh, we're still going 22, 3, 24, 26. And there we go. 5 extra wagons. 5 extra wagons for free. Moving stuff with 5 extra wagons on the end of it. There's a benefit there. Yes, there might be additional cost because guess what? To move 5 extra wagons takes a bit more energy. So there's extra fuel. But moving 5 extra wagons in a train that's already moving compared to trying to take an extra train to move those 5 extra wagons, or even if you roll it into a continuation service, it's not as efficient as just putting 5 wagons on the end of an existing train. Benefit for free. Big, big plus. You need to make a difference. We need to turn findings into business as usual activities. Because if we don't do that, the findings don't get picked up, we don't get the benefits. So this is what we did. We did the research. We had the justification, the robust engineering justification for the changes. We developed the model. We then thought to ourselves, well, who's in charge of making those changes? Well, yes, the operators want to take advantage of the changes, but are they the ones that set the rules in this space? The answer is no. 2 people. RSSB. Oh, that's us. That's easy. Excuse me, Toby. Got this idea here. Can we update the standards? Toby says, yes, we can actually. We take it through standards committee. It gets approved. They're incorporated into the standards. They're in the standards right now. They weren't there before. Network Rail. You own that thing called the Trailing Loads book. Can you update it, please? Well, yes, we need to be a bit cautious. We need to do some testing, but we think we can do it. And guess what? By the way, Aaron, we already have a bit of a program working to take those nasty Excel files that you are aware of and turn them into a digitized version, which allows the operators to challenge and look at what they might be able to haul from a trailing load limit perspective. Oh, great. Could we put that in there, please? Yes, we can. And I'm really happy to say that now these findings are incorporated here. This thing exists. It is now a business as usual activity. And that's the important thing. Don't just do the research. Make sure it's implemented. Make sure it's implementable and make it as easy as possible for those who can get the benefit to utilize the findings and get the benefit. And there has been big benefits. From a trailing load perspective, there are a Freightliner service. I'll just give some examples because there's a Freightliner service carrying aggregate out of Tunstead Quarry. That was previously carrying 20 wagons. It's now carrying 30 wagons. That's big. That's a big thing. I mentioned earlier about this isn't just couplers. It's also about tractive effort and it's about fitting in the timetable. We challenged all of those logics. We improved them. We're implementing them. And from that timetable perspective piece now, there were, again, Freightliner haven't been able to run certain freight services on the West Coast main line during the day in about a decade and a half. Because of the research, they've now got a service running during the daytime. Meaningful, easily to pick up results that allow change to happen on the industry. Tangible changes. Big, big, important tangible changes. So we spoke about one. We spoke about something that's quite tangible. Now, another thing. So I don't know how familiar the people are on the call with something called the digital automatic coupler. Now, unlike passenger services, and sorry, I just realized the time, I've gone on a bit. we were good. Digital automatic couplers, unlike passenger services, our freight trains are relatively dumb. You have dumb locomotives attached to dumb wagons. Those wagons, for the majority of the case, don't have any power, certainly don't have any kind of remote condition monitoring or sensoring on them. It's a big challenge. The EU have come up with a solution to that. They've got this thing called the digital automatic coupler. It provides power down the train. It provides a digital backbone so that you can have sensors on there. You can go and look and see what's going on with my train. So a good digital and power backbone. Is it right for the UK? Well, they said, look, we've got this thing, but we think it's, for the UK, is it right? We operate our freight trains in a slightly different way. We don't do as much marshalling. We don't split our freight trains up and put them back together in different ways as much. They tend to stay in similar formations for a lot of the time. So is it the right thing for us? Oh, let's go have a look. We know what the benefits are for DAC. It provides that backbone. It allows data to be transferred across the train. It allows, and a big point is that it can automatic coupling, so it can attach and detach itself without the need for somebody to get in between the train and couple and decouple the train. Big benefits, safety benefits, operational benefits, but big cost. Is it worth it in the GB context? So we asked the question, what's the cost? 2,000 of these things, given the amount of wagons that are on the network, given the amount of locomotives that are on the network, and the cost, a cost of between 300 and 400 million pounds to do that transition, which is a lot of money, but it's exacerbated by this one problem. A digital automatic coupler is not compatible with today's current couplers on the network. So you need to, if you're going to run some trains with digital automatic couplers, you need to have a converter so that you can connect current wagons with wagons fitted with digital automatic coupler. That's a lot of cost, that's a lot of extra effort. There are big benefits though, big benefits. And that's really good because it's about power. It's about enabling those safety benefits through removing people, ballast, boots off the ballast. It's good. By having power, it enables more remote condition monitoring, better predictive asset maintenance. But that's an enabled benefit. The digital automatic coupler doesn't do it itself. What it does do is it gives you the infrastructure to then fit those sensors, to fit that technology, which allows that intelligence. So that's enabled. So what's the message? Well, actually, yes, there might be benefit. Yes, there might just be a net benefit, but that journey is really hard. It would take multiple years to transition. And really, actually, from a cost benefit perspective, if you're just about making a cost benefit ratio of 1, it doesn't really make sense. Doesn't really make sense. So the industry asked the question, should we do this? The answer came back, look, you can, but the benefits, they're there, but it just about pays for itself. But that benefit case is now getting eroded. Why? Well, because I mentioned a lot of the benefits are due to those enabled benefits, digital, the monitoring, the intelligence piece. But there are other ways to deliver that intelligent piece. There are other initiatives going on right now. In fact, last year, we had an intelligent wagon demonstration where they showed, quite simply, just jumper cables, cheap jumper cables running down a freight train. That enables a good amount of power and a good amount of digital infrastructure for a fraction of the cost. And it enables you to incorporate intelligence into those wagons. And here you have a node which then you can plug in different sensors, different capabilities to enable you to gain that intelligence. And at a much cheaper cost, much cheaper cost. These things they're increasing, they're £50 per wagon per month. That's all it's adding on to it. That's much cheaper than the digital automatic coupler that we mentioned earlier. But then there are other solutions as well. The solution I just talked about, the intelligent wagon, not to be confused with this thing here, the iWagon. But the intelligent wagon still relied on physical infrastructure, that physical cable. The iWagon here, this is a venture between Knorr-Bremse and VTG, wholly wireless. It's self-powered, so it provides that intelligence in a wireless way. And all of a sudden, those benefits that DAC provide, well, you can do it in a much cheaper way. A lot of those benefits can be delivered in a much cheaper way. So all of a sudden, the business case for DAC becomes further and further eroded. And not only that, but it can tie into other systems as well. And again, that's what's happening here. There are a number of other remote condition monitoring systems that are worth mentioning, just below, being one of them. And then we know that there are further remote condition monitoring systems, not just on the train, but also on track. And that's some of the work we've been doing as well. Actually working out how do we do this. And I'm just touching on this very briefly to say we're currently working with Network Rail and the freight operators to work out actually what's the right mix of remote condition monitoring solutions and where should we put them to maximize our bang for our buck. Is it on the train? Is it on the track? Well, the answer clearly is a bit of both. But we're working to make sure we understand the best way to do that. Other research that we're doing, again, just touching on this a bit, is I mentioned about going faster. Now, currently, we've got freight trains going at a maximum speed of 75 miles an hour on the network. They've been going 75 miles an hour on the network since the 1960s, and they've not gone faster since. We've got passenger trains that have gone much faster. We've got cars that can go much faster. But fundamentally, our freight services have been maxed out at 75 miles an hour for decades. Why is that? Well, a lot of reasons, a lot of very good reasons. One of those, not all of them, one of them is the challenge of aerodynamics. Because the faster your freight train grows, the greater the aerodynamic force that train creates and exerts on things around it as it passes. And I'm sure you'll have seen videos from places and events like Didcot where there was a pram. Luckily, there was no baby in it, but a pram that hadn't, the brakes hadn't been left on, the brakes were off, and a freight train passed the platform, and that pram was dragged into the platform train interface onto the track. We need to make sure if we are going to run faster, we do it in a safe way. Aerodynamics is one of those questions. And so we funded research to determine if we can. And this is the train rig up in Derby, actually built by BR. But this is a scaled down model that enables us to test the effects of different trains running at speed to determine and characterize the aerodynamic impact of different train services at different speed, to determine whether, in this case, whether those aerodynamic forces that we create are sufficiently large to cause concern, or whether we can manage them through the way that we operate our trains. I'm happy to say that actually we found it will be possible to travel at speeds above 75 miles an hour in a safe way for freight trains. Lots of caveats, lots of other challenges as well. We've got to think about vehicle dynamics. We've got to think about gauging. All of those questions still to be addressed and work that we are doing to address. But fundamentally, one piece of the jigsaw has been answered and we're continuing to do work in that space. Sorry, I mentioned earlier, trying to get heavier freight trains on the network. One of the biggest challenges we have is in our heavy axle weight services. We're carrying per wagon a lot more stuff, a lot more weight in them. So our axle weights are much heavier. We have a lot of things like weak bridges that are of an age that can't maintain the level of heavy axle weight traffic over there that we would like. So making sure we're keeping up to date with the condition of those wagons and modelling and monitoring the progression of the condition based on further traffic going over it. That enables us to manage extra traffic in a safe and efficient way. And we're working with the University of Southampton, who have a centre of excellence in infrastructure management, to develop tools and modelling capabilities to support this. So they're just a few examples of the research that we're doing and how we're helping to make an impact in the industry. And I mentioned before, it's not just about doing the research. It's about taking that research. It's about delivering the research. It's about publishing the research. And previously in work that we used to do was all about communicating, but we realize it's really important. We need to monitor and support the implementation of our work. We need to make sure there's good planning. We need to support the initial adopters of the work. We need to take the lessons learned from those initial adopters of the work and of the findings and make sure lessons learned are communicated so that we have further adoption and further integration into industry. So that fundamentally the knowledge the innovation becomes business as usual, and it's no longer research, it's no longer innovation, it's just how we do things. It's very important. What we do is we monitor, what we do is we capture lessons learned, we communicate that out to industry. Where we find ourselves in a valley of death, RSSB also looks to see if we can support those initial adopters. Can we help through our expertise, through our knowledge, through supporting a trial to actually get the research into the industry and delivering the benefits we know it can deliver. And I have to say, we're doing quite well. We're not doing great, but we're doing well. We have a number of projects which have been delivered. Now, one of the things we have to recognize is this is research. We test a hypothesis. Sometimes that test and sometimes the answer comes back as being not the thing we hoped for. That is okay because it's research and it's robust research. We thought we could do something. We tested whether we could. The answer came back, no, you can't. Sometimes that happens. And it's important that we do that research. We publish the findings so people know that. Other times we test a hypothesis and we show that we can do the change. This is called our significant research outputs. This is the stuff where there's an opportunity to make a change in the network. We look to push it. And we look to push that research through those different stages I mentioned: planning, first adopters, more people using it, business as usual. And from the research that we've delivered in the last just over a decade now, we've made really good advances. You can see of the research we've delivered, we've got 42 of those findings which are being considered as full. That is to say that they've been adopted, they're taken up, they're just part of the railways way that we do things now. That's only 20% of the research that we've delivered. Pretty proud of that. It's a really good thing. And of all of that research that we do, it's important to say nearly 2/3, just over 58%, are findings that can be picked up, can be used, and are going through the process I've just mentioned. And if we continue to work to monitor, to push up the findings so that we're not just planning, but there is actually a benefit that has been seen somewhere on the network. And as you can see here, nearly 70% of our research is not just research findings, not just people talking about using them, but they're actually being used. So, RSSB research, what do? We look to support whole systems optimization. That's where we are, that's where we can support the trailing loads limit piece I mentioned. What was it? Well, yes, it's about the coupler strength, but it's about where that train is going. It's the gradient. So it's the infrastructure manager's data. It's the rolling stock information. It's the freight train. It's the freight train's information. We need to get all of those things together to get the insight. That's what we do. You've spoken about those examples where things are different now on the railway today because of the research. There continues to be more. I could go on. I'm glad that I'm not sure. We're continuing to look at safety. We're continuing to look at maintaining and building our inefficient operations on the network. And we continue to support implementation of those findings into the industry. So let me finish with the message that I started off with. If you've got an idea, if you want to do something but you can't, tell us, and tell us why you can't do it. Thank you very much.
Thanks, Aaron. That was really interesting. Are you okay if we do some questions?
Yes, sorry, I've just looked at the time. Sorry.
Really good. I've definitely got some questions, but maybe anyone else in the room first? Go for it. I'm going to use the blue box. That's what Toby told me to do. There we go.
Questions. I was standing on the South Hemsel station and I noticed that all the locals had stepped back. And I was first thing, and the Freightliner came through with missing containers, and I got a real bashing. So I wouldn't be happy about going above 75.
Yeah.
Not in those conditions.
And that's part of the things that we're finding. So it's the difference between a blanket rule and applying that rule proportionately and appropriately. Going above 75 miles an hour through a station platform, absolutely not. The research tells us that. Don't do that. But on the West Coast Main Line, where you have 20 miles before the next platform, where you might be on a middle line which doesn't have a platform, yeah, there's opportunity to do it then, but not everywhere. I agree. And not I agree. The data shows. Far more importantly.
Any other questions?
You rather than mind holding it. Yeah, thanks, Aaron. That was a really, really interesting presentation. There's clearly a lot of great stuff going on. You touched on the sustainability credentials of rail freight, and that if road get their act together, decarbonise their fleet of vehicles, then perhaps rail freight no longer becomes the most environmentally friendly option for freight. So I wondered, did you have any thoughts on sort of the challenges around that and around electrification? Because it's not easy for passenger vehicles. It's possibly even more difficult for the freight vehicles when they've got to get to some more obscure locations. When you've had any thoughts on that?
A couple of things going on. So I mentioned, so there's new locomotives coming online. So there's two big ones at the moment. So there's the Class 99s. This is a bi-mode solution built by Stadler for GBRF. That's primarily an electric locomotive with a diesel engine attached to it. There's also the ROG, the Rail Operation Group, their Class 93s. Those are tri-mode, diesel, electric and battery. Now, there's opportunity with battery to incorporate the last mile. So that might be a solution where we're having challenges for that last bit of electrification. Now, it's a bit more of a question for, the answer obviously is more OLE, but that costs money that the industry frankly doesn't have at the moment. But I know that Network Rail are doing some really good stuff. We had the TDNS, and that fell off because it didn't have the funding. And I know that they're looking to see how they can do a light version of that, which really gets those benefits. We'll see where that gets to. I know that there's still some questions and challenges around that. It is challenging because more than passenger with freight, it's not just a question of is there wires up, it's is there juice in those wires. That's a big, big challenge. These freight locomotives are particularly power hungry. And if you have busy bits of the network, which are already close to capacity from a power perspective, because you've got a lot of passenger trains going through them, asking for more power to deliver more freight services using electric 90s or 88s or whatever it might be, is 91s might be, is challenging. Probably the answer is we can't do it at the moment. We need to be more smarter about it. And there are ways that we can be. And with the new traction, with the new locomotive, with the traction packs that they have, that's a step in the right direction. It also enables us to communicate with the infrastructure as well. But again, we need slightly more intelligence in how that happens. But that's fundamentally, we need more wires up, we need more power. But those other, so going back to those other opportunities of battery will help with last mile stuff.
Anyone else? I'll ask one just quickly. In terms of safety and how you justify that, the changes to safety, I should say. So things like, for example, the coupler changes. If you're making effectively a rule book change that says, yes, we think these couplers are strong enough, there must be an element of risk in doing that, fatigue and all the rest of it. You're changing the use case. How, and I get you can do quite a lot of analysis, but somebody still has to presumably put their neck on the line and say, yes, this is the right thing to do. How is that managed?
As anything in the railway, by committee. But in that case, what we found, and I touched on it in the talk, was that the analysis to determine what those margins and those factors of safety are, our knowledge has improved. So the level of conservativeness around that has decreased because we have greater certainty and knowledge thanks to the modelling capabilities, additional testing that have gone on in the last 50 years. And so it's through that weight of evidence that you're able to make that justified case because it's out there. It's out there, and it's more in that particular case anyway that these things weren't challenged. Mm-hmm. The insight was there. We just asked the question, can we do something differently? When we did, and that's why, as you see, even though the case was there and it was relatively simple, it still required a report that was nearly 200 pages in length to show that engineering justification to address all of the challenges that were there.
Is there anyone online who's got any questions? Just wave your hands. If not, Toby, you look like you've got one.
Yeah, I've had the pleasure of being involved in a freight gauging research project. One of the things that I learned from that is similar to the couplers, the tools are not particularly modern. And you may have heard of the J tables. I think there's probably maybe one or two people in the whole country that really understand how those work. And they're close to retirement age, so I think there's opportunities there for sure, in terms of making that process easier for the freight operators, so they can plan their freight movements easier, get their square boxes through the round holes. So is engaging is that on the radar? Things like J tables, bringing this up to date. We've got some great tools in the gauging world, but this one just seems like it's not kept up with the times.
So we're doing a lot in that space at the moment and learning two things on that. So absolutely, yeah. So we're actually doing new research to utilize those new modeling capabilities that exist to challenge existing gauging definitions. We've done that to some success. And this brings me on to the second point, which is a bit tangential, but I think important. We're learning lessons as well. About, was it 10 years ago now, we did a whole big research project to look at improving gauging. What did we do? We created all of the W7A, W8A, and we thought, great, we've got this new, we can be more flexible. Did that help? Not really. Why didn't it help? Well, because that required somebody to go around the network and say, is this bit of the network compatible with W7A, W8A, and so on and so forth? And guess what? That's only really just happening now. We learned the lessons from that, and that's used. So what we did this time, and what we're doing with our new research, is rather than saying, hey, let's create some new gauge definitions, let's challenge the existing ones. Let's use that new modeling capability to see whether we can sweat more out of our assets, be more clever about what we can actually get in terms of those boxes through those round holes. And that's what the research is showing us, and we've got more to do now, but we tried it first. We had a look at the W10, W12 gauges. We've got some real opportunity there. That's working its way through the changes, and then incorporating those changes into the J table as well, not just into the sectional appendix that says, yes, this bit of the track is compatible with a particular gauge, but also, guess what, this box wagon combination is compatible. So it's not just the train, it's not just the track and the infrastructure, but it's the train as well. So we are doing those things, trying to learn those lessons and hopefully making a good impact in that space.
Further questions? If not, then thank you very much. I thought that was really interesting. Thank you for the overview of freight to begin with. I think I definitely learned a little bit about the logistics of freight and how it goes around the country from that start. Great to see that the research that you're doing is making actual implementable changes. I think that's something that I wasn't really aware of, and enabling those couple of changes that must actually make a real instant, huge, big difference to the industry. Cheaper, presumably, for the operators to add those wagons on and gain gain some more profit out of it and cheaper for the end users at the end of the day by having those longer trains. And I think it's really interesting how it's done it's almost kind of rowing back the safety. Somebody's put in a blanket sort of rule, for example, the gradient stuff, somebody's gone on the side of safety to begin with, and then you've gone and justified to say, no, that was far too safe in the first place. We can get some benefits by applying engineering and reducing the, I'm not sure the right word is, reducing the safety margins, but still keeping it safe to...
taking advantage of modelling capabilities, analysis capabilities that fundamentally weren't there in the 60s and 70s.
Yeah, absolutely. Right, well, thank you very much again, and everyone join me in saying... anyone who'd like to join us for a drink after this, go to the Swan for walk.